This is lesson 8.2, part 4. We're going to continue question 4 over here. We had started off by drawing our triangle, and now we need to figure out the height, the altitude of the rocket, which is represented by point C over here. And so what I want you to notice is that we have two angles and a side. None of those angles are opposite to that side. We could actually find another angle. And I'm jumping ahead here a bit. I just want to find that other angle just in case it helps us out. And then we'll go and we'll plan our strategy a bit more here. So our other angle over here, we have two triangles here, but the angle that we're going to find really is the angle, assuming this was the one larger triangle. So we would simply do angle C is equal to 180 minus your 41 plus your 75 there. So take away those two angles from 180, and then you get your final angle. So minus 41, minus 75, and we get angle C is equal to 64. So angle C, 64. So our goal here, remember, is to find this x here. Now you'll notice we have a right angle triangle. Oftentimes when you have a problem where you have right angle triangles and triangles that are oblique, that are non-right angle, because we have a non-right angle triangle as the big one, and then two right angle triangles as the small ones there. And the reason I know it's right angle is because usually when I ask for height of a triangle, that's going to be 90 degrees there. And don't assume this 20 can be split into 10 and 10. It can't, because there's different angles here, so it's not 10 and 10. It's not an isosceles triangle. If it was an isosceles triangle, you'd have two identical angles there. So those are not the same lengths, 10 and 10. Doesn't work out that way. So what we can do is, and we're going to see our plan, we're going to have to use two things. We're going to have to use sine law, and we're going to have to use trig ratios. And my first, I guess, pre-planning was missing angle. Meaning angle C. So I did that just to make sure I had enough information. So what I can do is I can actually find one of the sides of the larger triangle, because I have two angles and a known side. I could either find side little a or side little b. So I have angle, angle, and a side opposite to it. That can work. And so, since I have an angle, angle, and a side opposite to it, I call that situation AAS. Angle, angle, and then side opposite to it. So, what I'm going to do is, I'm going to try to find side A. So that's our first step. Find side A. So I know that my sine law is going to be A sine A over C sine C. Why did I choose C? Because I know C. I need to have at least three known values to find the unknown. And so when I plug in the information, I'm going to have A sine of the angle opposite to A, which is 41, which is equal to C, which is 20, over the sine of the angle opposite to 20, which is 64. And now I can solve for A by sending 41 to the other side. So I'm basically multiplying everything by 41 here, by sine 41 here rather. So sine 41, like that, is equal to 20 sine 41 over sine 64. And so the sine 41 cancels out, and then I get my answer as being A is equal to, so let's go put that in our calculator. So again, make sure you're in degrees mode here. Sine 41 equals, divided by sine 64 equals then times 20. And I get, I'm not going to round too much right now. Well, let me see, how many decimal places do I want? To 1 decimal place. So I'll round to 1 just to keep it consistent. 14.6. 14.6 kilometers. So I found that. This is 14.6 kilometers. Now that's not the height. That's not the altitude. I'm still looking for x. If you recall, we have a right angle triangle here. So now that I have a right angle triangle, I can use a trig ratio. I know that, let's call this b, sine of angle b is equal to my opposite over my hypotenuse, which is sine of 75 is equal to x, which is my opposite, my height. So this is part 2. Find x over the hypotenuse, which I found of 14.6. And so now I can solve for x by multiplying by 14.6 on both sides. So I get 14.6 sine 75 is equal to x times 14.6 over 14.6. Cross that out, cross that out. I get 14.6 sine 75 is equal to x. So my end result is x is equal to, so 14.6 times sine 75, make sure it's in degrees. I get x is equal to 14.1 kilometers. Therefore, the altitude of the rocket is 14.1 kilometers. And so what we did here is we had to use a sine law to find an unknown side here. We did the sine law because at first we started off with a triangle that was not a right triangle, so an oblique triangle. And then once we had that side here, we were able to use one of the trig ratios to find the x here because we were dealing with a right angle triangle. And so that only required that we knew one of the sides and one of the angles to use that trig ratio. So sometimes you will have to use a combination of both when it does result in you having a right angle triangle within a triangle that's not right angle. So let's go start number 5. We might not have time to finish it, but we'll at least have time to start sketching it and planning out the problem. So we have 2 helicopters. They're flying at the same altitude. They spot a boat in distress on the water below and between them. The helicopters are 1.2 kilometers apart, and the angles of depression to the boats are 53 and 42. The Coast Guard is trying to determine which helicopter to send to respond to the distress call. Which helicopter should fly to the boat to rescue its passengers? Round the 2 decimal places. So let's see what the question's asking. That seems a bit complicated at first. So I'm going to draw 2 helicopters in the sky here. A and B. And we know they are 1.2 kilometers apart. And when they look down at the boat's in between them. That's what the question says. It's in between. That's why we know not to draw it over here or over here. It's in between. This is our boat here. We'll call this C. I should have called it B, but let's call this C, our boat. Angle, doesn't really matter which one. Let's say that A forms an angle of depression of 53 degrees and B forms an angle of depression of 42 degrees. And so we want to know which helicopter, so we'll call this helicopter A, this one here helicopter B, should go down to rescue our boat. C. So we're basically saying which helicopter is there a shorter distance? Which helicopter is a shorter distance to get to the boat? Helicopter B or helicopter A? In other words, we're looking for side A, we're looking for side B. The reason this is side B is because it's opposite of angle B. The reason this is side A is because it's opposite of angle A. So what we know is that if A is less than B, then heli A should go. If B is less than A, then helicopter B should go, because there's a smaller distance. So we're basically using our sine law to find B and A in order to determine, I actually made that conclusion wrong. So you have to be careful here. If A is smaller than B, then helicopter B should go. So hopefully you spotted that. Helicopter B should go because A is the distance between B and the boat. If B is smaller than A, helicopter A should go. Because B is the distance between A and this boat. So if A is smaller than B in terms of length, helicopter B goes. If B is smaller than A in terms of length, helicopter A goes, right? That's why your triangle is important to draw. So let's start off by finding the length of B. Do we have enough information to do that right now? So we have an angle opposite of B. That works. And we do have an angle, and we have a known side, so we have a side. We have angle, but the problem is, if we want to find B, we need something else. For our known side, we need a known angle, and we do have that. We do have this known angle here. We just have to go find it. It's indirectly known. So let's go do that. We'll do 180 minus the 42 and the 53. And that would mean that angle C would be 180 minus 42 minus 53 is 85. Angle C is 85 degrees. And so what I know is I want to find the length. So I know that B over sine of B is equal to length C over sine of C. And so my B is unknown. My angle B is 42, it's the opposite of side B, is equal to my C, which is 1.2 kilometers, over sine of the angle C, which is opposite, we just found it, 85. I can multiply both sides by sine 42 or just send the 42 to the other side, so I get sine 42 times B over sine 42 is equal to 1.2 sine 42 over sine 85. And so that cancels out the sine 42, cancels out the sine 42, and I get B is equal to sine 42 equals, divided by sine 45 equals, sine 42 equals, divided by sine 85 equals, not 45, times 1.2, and I get, rounding to two decimal places, I get 0.81. 0.81 kilometers. So I can label this as equals 0.81 kilometers for helicopter A to get to the boat. So let's go and start our setup for A over here. We won't have time to finish, but we can at least get it set up. So we know A over sine A is equal to C over sine C. We'll finish in the next video.